In 1865, a chemist named Auguste Kekulé had spent months stuck on a single problem. He knew benzene was made of 6 carbon atoms and 6 hydrogen atoms, but he couldn't figure out how they were arranged. Late one night, half asleep by the fire, he saw a vision. A snake curling around and biting its own tail. He woke up and immediately sketched benzene's structure as a ring. It was correct. It's still taught in chemistry classes today. Kekulé wasn't the only one. The sewing machine's needle design, the periodic table's structure, and entire pieces of music all reportedly arrived fully formed in someone's sleep. Why do we dream, and does anyone actually know? Here's what's strange. You'll spend roughly 2 hours dreaming tonight, whether you remember it or not. Multiply that across a lifetime, and the average person spends about 6 years of their life dreaming. That's an enormous biological investment, and for something that expensive, evolution is usually ruthless about cutting anything that doesn't earn its keep. So what is dreaming actually for? You'd think after a century of neuroscience we'd have a clean answer. We don't. What we have instead is several competing theories, some that flatly contradict each other, and no consensus on which one is right. Let's start with the least romantic answer. In the 1970s, Harvard researchers Alan Hobson and Robert McCarley proposed the activation synthesis hypothesis. During REM sleep, your brainstem fires off essentially random electrical signals. Your cortex, the part of your brain responsible for meaning-making, receives this noise and does what it always does, or tries to build a story out of it. On this view, a dream isn't a message. It's your brain's storytelling circuitry firing on nothing, the same way you might see a face in a cloud. It's a compelling theory because it explains why dreams are so weird. Random inputs produce random narratives, but it struggles to explain something else. Why dream content isn't actually random at all. It's eerily consistent. Anxiety dreams cluster around exams falling, being chased. Grief dreams cluster around the people we've lost. If it were pure noise, you'd expect pure chaos, not recognizable patterns across billions of dreaming brains. The next major theory flips this entirely. Dreaming isn't noise, it's filing. During REM sleep, brain scans show intense activity in the hippocampus, your memory hub, replaying fragments of the day. The theory is that dreaming is your brain sorting today's experiences, deciding what gets bolted into long-term memory and what gets discarded. And dreams are simply what that sorting process feels like from the inside. This one has real experimental backing. People deprived specifically of REM sleep show measurable memory impairments the next day, but it still leaves a gap. If dreaming is just administrative memory work, why does it so often feel emotional, even when the memory being processed is completely mundane? Which leads to a third theory, this one evolutionary. The threat simulation hypothesis argues dreaming evolved as a low-cost flight simulator for danger. Our ancestors who mentally rehearsed escaping predators in a dream at zero physical risk may have reacted faster when a real threat showed up. It's why nightmares involving being chased are one of the most universal dream categories on Earth, across wildly different cultures. It's elegant, it's also hard to test. You can't exactly run a controlled experiment on Stone Age survival rates. Here's where it gets genuinely strange. A more recent theory, borrowed partly from how artificial intelligence researchers describe a problem called overfitting, suggests something almost the opposite of memory filing. When an AI model trains too narrowly on the same data, it stops generalizing. It memorizes instead of learning. Some researchers now propose dreams exist to prevent your brain from doing the same thing. By injecting bizarre, low-probability scenarios every night, your brain forces itself to keep generalizing instead of overfitting to yesterday. Under this theory, the weirdness of dreams isn't a bug or random noise. It's the entire point. So, which theory is correct? Possibly more than one, possibly none, exactly as stated. What virtually every sleep researcher agrees on is this. Dreaming is too consistent, too universal, and too metabolically expensive to be an accident. Something is happening in that ring of imagery behind your eyes every night. We just haven't fully caught it yet. Which brings us back to Kekulé and his snake. Maybe the ring wasn't a message from anywhere mystical. Maybe it was his overworked brain, replaying the day's chemistry problem through a random neural filter, forced into a shape strange enough that it broke him out of the rut his waking mind was stuck in. Either way, tonight you'll do the same thing he did. You'll spend 2 hours somewhere no scientist has ever fully mapped. If you liked coming along on this one, there's more where that came from. Subscribe, and I'll see you in the next dream.